Hello, Assalamualaikum everyone. I hope you are all fine. So today's lecture is our lecture number 24, and it will be about mobile networks. We have discussed about the wireless network in our previous lecture, and now we will discuss about the mobile network, what is mobility, and how the vocabulary of mobility has been handled by a wireless network. So we have discussed about the wireless network in our previous lecture. In this lecture, we will be discussing about what are mobile networks and how mobility has been handled by a mobile network. So let's begin our lecture. So firstly, let's see what is mobility. What's meant by mobility? So initially, the internet or the telephone networks are designed assuming that the user are static. That means user isn't changing their location during the connection or the call, and also the user accesses the network always from a fixed location. So initially, the networks were designed for the user to be static. But as soon as the era of wireless networks advent, the concept of user being mobile is being introduced. So in case of mobility and portability, the mobile network is a one in which the user can move from one location to another location, and there is a concept of portability as well. What does portability describe? A radio terminal that can be used by someone at walking speed, which is your, for example, your cordless telephone at home or your walkie-talkie, in which user use this telephone set using at a walking speed only. However, the mobility describes that the radio terminal or the user is attached to a high-speed platform, and the user can move at a high speed as well. So, the example can be thought of as a cellular telephone in which user is using in a fast motor vehicle, and user location is being changed after every some time. So in that case, mobility describes the user is being attached to a network which is using a high speed platform as well, and user is being mobile. It is not at a walking speed. It can be at walking speed, but usually the user is mobile and is going at a high speed. So there can be two degrees of mobility. uh, First one is our walking user. Walking users are very low speed users, and they have a very small roaming area, and they usually uses a high bandwidth and low latency access, and these type of users are usually walking, and they have a very small walking area or a very small roaming area, but their bandwidth is high, and they are using a low latency access to the network. Whereas for the vehicles, it means the user speed is very high, and they can roam a very large area, and they can cover a large area as well, and which means they will be using a low bandwidth and high latency access, and we uses the sophisticated terminal equipment called as cell phones for their mobility for their mobility and their network access as well. So how the mobile network will be different from a wireless network. So we will see some basic concepts of a mobility. Firstly, we have a home network, or we say that to be a permanent home of a mobile. Okay, and usually where the user resides from and connected from the particular location to a network. And home agent is the entity that will perform mobility functions on behalf of your mobile, and when mobile is remote. And permanent address is the address in the home network that can always be used to reach the mobile. So home network will be the permanent home of the mobile, or you can say the user, and the home agent will be the router from which the user is being connected, and the permanent address is the one which is been assigned by this home agent to the user, and through this address it can always be reached to the user. And then we have a visitor network. Suppose now the user has been moved from this home network to something called as to be a visitor network, and visitor network is the one in which network is the one in which the mobile currently resides, and the permanent address remains constant. However, a new address called as a care of address has been assigned in this visitor network. And foreign agent is an entity that performs the mobility function on behalf of the mobile device, and it will assign a care of address to the user. And this process of assigning a care of address we will see in this lecture as well. And we have called a correspondent, which wants is correspondent is a device which wants to communicate with the user, or you can say your mobile device. Basically, this is our destination, the correspondent, and this is our source. So that's how some basics of mobility. Now, how this mobility will be handled? So first strategy is to let the routing protocols handle it, this mobility approach, and which means the mobility from one permanent home to the from basically the home network to the visitor network. First approach is to let the routing protocol handle this mobility from home user to the from home network to the visitor network. In this case, if routing protocol is handling this mobility, then the routers will advertise the permanent address of the mobile via the usually using the routing table exchange, and the routing table will indicate where the mobile is being located, and there is no need to change the end system or your mobile systems as well. And if we second approach is to let the end systems or your users handle this mobility. And in this approach we have two sub approaches as well. First one is the indirect routing, and second one is the direct routing. Indirect routing is the one, in this case the communication from correspondent or your destination to the mobile goes through the home agent, and then it is forwarded to the remote. And however, in the direct routing, the correspondent gets the foreign address of the mobile and then sends directly to the mobile user. So let's see how this will happen. The routing protocol, or the approach number one, that is let the routing handle it, is not much scalable because of the number of users are being so many, that are in millions of mobiles. So first one is not feasible, because whenever a user changes location, routing tables will be exchanged, and that will lead to the non-scalability of the routing protocols. We can handle this mobility using the end system approach, and in which we have indirect routing and direct routing. So let's see how the indirect routing and direct routing will work. Firstly, let's see the registration of a mobile device, how this will be done. This is our example that in you can see home network here, where the permanent address, or you can say user has been assigned a permanent address, but this is the visitor network where the user has been currently resided. Basically, it moved from our home network to visitor network because of the mobility. So first step is that the user or the mobile contacts the foreign agent on as soon as he enters the visitor network, it will contact the foreign agent. Second step is that the foreign agent will contact its home agent, that this mobile device is now currently residing in my network. And third step will be that the home agent will say that okay, I have updated this information. So end result is that now the foreign agent knows about the mobile device, and the home agent knows that where it's been resided currently now. So it is now resided in the visited network, which is now known uh, by the foreign agent as well, and as the home agent as well. That home agent now knows that his current user has been resided in a visit network now, and our foreign agent knows that it has added one mobile device in his visitor network as well. So first approach to handle the mobility is via the indirect routing, and in this case uh, foreign agent will contact the home agent, and home agent will done the routing of the packet on base of the correspondent. Correspondent knows about the permanent address of the uh, mobile device. So now first step is that the correspondent now send the packet to the home agent, because correspondent only knows about the permanent address. So in this case the home agent will not redirect the packet to the correspondent. It will do the routing now, because home agent knows that where this user has been resided. So it will forward this packet to the foreign agent where the user has been resided now. And third step, that foreign agent will receive the packet, and then it will forward it to the mobile. So and fourth step is that the user will now directly correspond, will replies the correspondent directly, that the foreign agent will direct the packet towards the correspondent now. So in this case the correspondent doesn't know where the user has been resided, and the packet is now in this case is been forwarded to the home user or the mobile user through an indirect route. So in this case you can see the user now, suppose the user moves to another network. Now it will register with a new foreign agent, and the new foreign agent will register with the home agent. So the home agent will update the care of address for the mobile, and the packets continue to be forwarded to the mobile, but with a new care of address. So mobility from which means that changing the foreign agent is now transparent, and the ongoing connection can be maintained. So the connection from the home network will not be disturbed. Now what will be done in case of direct routing? First step is that the correspondent will request about the will send the request packet to the home agent, and in this case home agent will say that you will share the location to the correspondent, that the user is now residing in this foreign agent, and now you can send the packet to the care of address of this user. And the third step is that the correspondent now knows about the foreign agent, and it will send the packet to the foreign agent, and user will reply back to the correspondent directly. So in case of direct routing we have overcome the triangle problem, because in case of indirect routing we were forwarding the packet from home agent to the foreign agent, and then on to another foreign agent, which causes so much delay. But in this case, in case of direct routing, we have overcome this triangle routing problem. And however, the correspondent is now non-transparent to the correspondent, and correspondent must get the carrier address from the home agent in order to forward the packet to the mobile user. So this was all about the mobility. Let's see how the cellular system telephones work. In cellular telephone systems, we will be accommodating a large number of subscribers over a geographical area, and the limiting coverage of each base station to a small geographic area. And why we call it to be a cellular network? Because they are being organized in the form of a cell. That's why we call it to be a cellular network. And let's see about the basic architecture of a cellular network. In this case, you can see here the cells are been formed in a fashion of hexagon shape, and each hexagon shape has some components. First one, you can see this cell basically covers a geographical area. And why it is being taken as to be a hexagon shape? Because the electromagnetic waves, or the waves which are used to transmit the wireless signal, are called to be as an electromagnetic waves. Electromagnetic waves follows the circular pattern of transmission. So the nearest representation, or the nearest possible representation that can be thought of as a circular pattern, is a hexagon. If we use a circle, then we can't cover the whole area, because there's some will be suppose this is our circle. If we cover a cellular network with a circle pattern, then you can see there this area or the area here will not be covered. So we can't take it to be a square, so because the square is not nearest to the circular pattern. However, hexagon is somewhat similar to a circular pattern, and it will cover this issue of non-covering the whole coverage area as well. So that's why a hexagon shape has been taken as to be the reference of cellular network. And this cell, the shape of cell is to be a hexagon, and this cell will cover a geographical area. And we will see what type of cells are being used, because there are different type of areas and there are different type of liabilities of each area. So this cell will be covering geographical region, and in this cell there are three basic components of each cell. First one is the base station, or we call it as to be a tower simply. The base station is similar as to the router, or you can say the access point in the Wi-Fi. And then we have a mobile user which is connected to the base station, and then there's an interface, we call it to be an air interface. It is a physical and link layer protocol between the mobile and the base station. So these three are the basic building block of a cell. And then we have a mobile switching center, and each base station is being connected through a wire to the mobile switching center. The wireless access is being provided to user by the base station. However, each base station is being connected to some combination of base station is being connected to mobile switching center. Mobile switching center connects the call to the wired telephone network, and it manages the call setup, and we will discuss how it will manage, and it handles the mobility. And then the mobile switching centers, or the MSCs, are connected to the public telephone network through a wire. And this is our wired network at the end. And now the first hop or the wireless access is up till the first hop, which means the base station, up till base station user is been given a wireless access. So there are two techniques for sharing the mobile to base station radio spectrum. First one is the combination of FDMA and TDMA. In this case, we will divide the frequency spectrum into frequency channels, and then divide each channel into time slots. You can see here in the diagram as well that we have divided this frequency spectrum into a frequency band, and then each band is being divided into a time slots. Third technique, or the second technique, is the one in which you can use code division multiplexers, which doesn't require this spectrum to be divided in frequency and then time. It just simply divides the channel into the codes. Different codes have been assigned. Now I have told you about the cell of the cellular communication network. There are four types of cell that can be used in a mobile network. Uh, the size of each cell is dedicated by the capacity demand. So if if you are covering a large area but the population or your users are very limited, then you can make a macro cell approach. And in macro cell, the covering area is very large, which ranging from several hundred kilometers to tens of kilometers. And these type of cells are mostly deployed in rural areas or very sparsely populated areas. And second type of cell is microcell, and these cover medium cell ranges, and it covers coverage area smaller than the macro cells, and their range are from several hundred meters to couple of meters. And these microcells are deployed mostly in a crowded areas, stadiums, shopping malls, or you can say in your urban areas. Third type of cells are your pico cells, which are very small and they cover very small areas, and their range is from maximum up to tens of meters. They uses very low power antennas, and they can be mounted on a wall or a ceiling. These type of cells are usually used in a very densely populated area or in offices, in order to cover the users in tunnels, lifts, and in some areas where users are living in a building, you can say in type of flats where in one building there are many users and living, hundreds of users are being living. If you go to Beijing or if you go to Karachi, you can see that a very huge number of people are living in a smaller area, so you will form pico cells there. And fourth, or in the last one, type of cell is the mega cell. These are formed by the LEO and the MEO satellite. These are usually used to cover the satellite communications. The highest range that can be achieved by the cell type is the mega cell. It can achieve thousands of kilometer range. Now let's see about the first cellular network, that was the 2G network. The network architecture of 2G was that each base station, or you can say the base transceiver station to be exactly, the BTS. Here is your BTS, the tower. Is suppose three BTS are connected to one base station system, the BSC, the base station controller, and then some couple of BSCs were connected to one MSC, and then this MSC was connected to the gateway MSC, which was connected to the public telephone network. And the user can be mobile and can enter the base stations, and it can have the mobility feature as well, but it was limited to the voice service only, the 2G network. And there were some weaknesses that led to the development of 2.5G. The weaknesses of 2G was that it uses circuit switch data modems that limited the data users in a single circuit switch voice channel, and the data transmission in 2G are very limited. The throughput is very limited, and the rate of same of or magnitude of data rate of designated speech corridor given in key specification of leading 2G technologies were being accommodated. However, users were not able to use the data communication or the data services. In 2G, original GSM and CDMA standards, which were originally supported maximum of 9.6 kilobit per second, were transmission rate of 9.6 kilobit per second was used for data messages, which you can say is very limited data rate for using any data service. So due to relatively small data rates, 2G standards are able to support limited internet browsing and sophisticated short messaging capabilities using a circuit switch approach. So these were some of the weaknesses which led to the development of 2.5G. So how we can upgrade to the 3G? These are the upgrade paths available for 2G standards to upgrade to the 2.5G and then later on to the 3G. IS-95 is been upgraded to IS-95B. The GSM were being upgraded to GPRS and HSCSD. However, IS-36, 136 and PDC were being upgraded to Edge and GPRS, and then these were upgraded back to the 3G technologies as well. You can see here. There are three TDMA upgrade options available for 2.5G standards. First one is the HSCSD high speed circuit switch data. Second one is the general packet radio service GPRS, and third one is the Edge, the enhanced data rate for GSM evolution. We will firstly see how GPRS were able to provide the services to user. GPRS provides the network packet network and retains the same original modulation format that were specified in the 2.5G standard. However, 8 time slots of GSM radio channel dedicated to GPRS individual user to achieve a maximum data rate of 171.4 kilobit per second, which means 21.4 kilobit per second will be assigned to one time slot. So there are 8 time slots, so multiply that data rate with the 28 multiplied by 21.4, which will achieve a maximum data rate of 171 kilobit per second. So that is much higher as compared to 2G. However, if you are upgrading to GPRS, then it means new routers and internet gateways at base stations, along with new software that will redefine the base station air interface for GPRS, are to be deployed in order to upgrade to GPRS from 2G. So second option that was for GSM was Edge, the enhanced data rate for GSM evolution. The enhanced data rate is a more upgrade. The Edge is a more advanced upgrade to the GSM standard, and it requires the addition of new hardware and software at your existing base station. So Edge was developed for the desire of GSM and IS-136 operators to have a common technology that will upgrade them for 3G high-speed data rate. So Edge basically introduces a new modulation format, that is a 8 PSK octal phase shift key, which is used in addition to the GSM GMSK modulation. So these were some of the upgrades from 2G to 2.5G, and in Edge we can achieve maximum data rate of 547 kilobit per second theoretically, and practically we can achieve 384 kilobit per second in Edge. So the architecture of 3G is somewhat similar to 2.5G. You can see that 3G introduces some type of IP based things in core network. This is our core network from radio network controller onwards, the SGSN. This is the serving GPRS support node, and the GGSN is the gateway GPRS support node. And the key differences were that the new cellular network operates in a parallel with existing the current cellular voice network. The voice network is unchanged in the core. However, the data network operators is somewhat changed at the user end. So this is our radio interface up till your base stations, and the radio access is up till your access network. The RAN, the radio access network, is up till the radio network controller, and then we have a core network up till the GGSN. There were some standards developed for 3G. First one is the WCDMA. The WCDMA is has a primary focus on 3GP, and it can support up to 2 megabit per second. That will allow multimedia and streaming audio and video applications as well to be accommodated. And the WCDMA uses a single 5 megahertz channel, each supporting 100 to 350 calls simultaneously, depending upon your antenna sector, propagation condition, user velocity, and antenna polarization. However, in order to upgrade to 3G, new and expensive BTS equipment and deployment issues were being raised for 3G. For 3G CDMA, 2000 second for 3G second standard was developed to be CDMA 2000. and it has a air interface being changed and it applies a single 1.25 megahertz channel is used, and it can support twice as many as voice channels to be as equivalent to 2G CDMA standard. This was introduced by Qualcomm, and it uses 1x EVDO enhanced voice data only, dedicating radio channel to the data user, and supported greater than 2.5 to 3 megabit per second of high speed packet throughput per user. However, the voice support, the EBDV, the enhanced data voice support both voice and data user with a data rate of up to 144 kilobit per second. And then we have something called as a 4G. 4G is also known as a mobile broadband everywhere, and in this case user will get the speeds in hundreds of megabit per second, and basically means a mobile multimedia communication, and it will support the global mobility as well. And in this case the network core is all IP based, and it is based on an OFDMA technique which uses multiple antennas, MIMO based technique, and dynamic channel allocation, and channel dependent upon scheduling for time varying condition as well. So 4G is much more advanced now, and it can support data rates in hundreds of megabit per second. Now the mobility, how the mobility will be handled in a cellular network. The home network basically is the one where network of cellular provider provides use the subscriber to, and it will have a home location register. It's basically a database in the home network containing the permanent cell phone number, profile information, your information about current location as well, from where now user has been located now. And second one is the visited network. The visited network is the one where the current mobile device has been resided currently. It will have a visitor location register VLR. It's basically a database with the entry for each user currently in the network, and it could be the home network as well. So the wireless and the mobility we have discussed so far in these two lectures. How will they have an impact of on higher layer protocols? Logically, this impact on higher layer protocols, the transport layer and the application layer protocols, will be very much minimal, because the best effort service model remains unchanged. The TCP and UDP can also run over the wireless and mobile network as well, but there will be some differences performance wise. How? Because the packet loss, delay, which are due to the bit errors, discarded packets, and handoff conditions, the performance will be very much lower as compared to the wired network, because the TCP interpret loss as a congestion, so it will decrease the congestion window unnecessarily as well. So there are delay impairments for real-time traffic, and the bandwidth is limited for wireless network because of these. We will have a performance issues as well. So wireless and mobile network are very much differ if we talk about the performance, because the in case of fixed wireless users, the performance will be better because user will not be moving from one network to another network. However, in case of mobile user will be frequently changing his location. So there will be no impact on the higher layer protocols if we talk about logically, because TCP and UDP services remain same and they can run over the wireless and mobile network as well. But if we talk about performance, yes, there are huge differences because of the packet loss and delay and the working of TCP as well. So and also due to the nature of wireless network as well. So that's all for today. Inshallah, we will meet about in our next lecture about the network security aspect as well. So goodbye for now. Allah Hafiz.